Assalamu alaikum everyone. It is really a great pleasure for me to present my paper here at Military Institute of Engineering and uh, Institute of Science and Technology in ICEICT 2018. The topic of my presentation is presumption method for detecting and analyzing human mental behavior by employing easy signal. We are four authors from Department of Tripoli, Manoj Army University of Engineering and Technology, Bawet, Khadirabad Cantonment. This is the outline of my presentation, and let us switch to the introduction. So, as we are working with easy, at first we have to know what is easy signal. So what do you mean by easy? Easy is the short form of electroencephalography. Um, it is used for electrical operations in the brain, and actually easy is accomplished with electrical impulses that are produced in the brain, and it is called sometimes easy fingerprint because uh, it varies from person to person, like just fingerprint. So it is always used for biometric identification and authentication. Also, it is called signature of our brain, and it is difficult to mimic or to duplicate, and it is also impossible to steal. Well, so what are the different rhythm of easy signal? um, Easy signal have total 5 rhythms, that is delta, theta, alpha, beta, and gamma. And delta varies from 1 to 4 Hz, theta 4 to 8 Hz, and alpha 8 to 13 Hz, beta 13 to 30 Hz, gamma 36 to 44 Hz. And uh, delta signal is originated from the frontal lobe, theta from the temporal lobe, alpha anterior lobe, beta frontal occipital lobe, and gamma the cortex lobe. Well, and these signals and these frequency bands are prominent in different conditions, like in deep sleep. Delta band is prominent, right? And in drowsiness, the theta band is prominent. When it is long term meditation, then gamma band is prominent, and these are proved by many publications by different researchers. Well, so what are the applications of EEG actually? Well, EEG mostly used for diagnosis of seizure disorders, mental disorders. Sometimes EEG is used for identifying problems with changes of behavior. Sometimes after head injury, it is used to detect where the problem is in the brain, and sometimes it is used for anesthesia. Uh, uh, After anesthesia for diagnosis, and EEG also can be used for monitoring of brain function, and most importantly it is used for biometric identification and authentication, like uh, fingerprint. Well, so now let us see what is human mental behavior, because our paper works with this. So mental behavior actually is something which are health conditions or disorders, and it sometimes affects the mode of thinking and behavior. And the normal human mental behavior all of us have is happiness, sadness, anger, surprise, or fear. All of the persons, all of the human beings to have this type of mental behaviors. But when these type of behaviors come to excess or severe limit, then these symbols occur, that is depression or anxiety disorders, schizophrenia, eating disorders, or addictive behaviors. Well, so what are the normal human behaviors or human mental behaviors? At first, anger. So what is anger? Anger is the feeling or showing of annoyance, displeasure, or hostility, or full of anger. What is surprise? Surprise is something which is a result of unexpected event or sometimes astonishment. What is fear? Fear is a feeling of induced or perceived danger or threat. Well, so what is about our research question? Our research question is to identify the human mental behavior, whether this behavior is happy, or whether he is sad, or whether he's in angry state, or in um, any type of condition. So here you can see we have to, our task is to identify a person whether he is in a specific mental behavior, like whether he's happy or whether he's sad, or whether he is in anxiety, or whether he is amazed, or he is totally surprised. Well, so this is our proposed algorithm to identify a person with his mood. And at first we have to check the easy signal acquisition from human brain. Then we have to we did use some sort of systems for easy signal acquisition. Then we have to pre-process the signal before feature extraction. So at first we have to filter the signal because there are some line frequency uh, 50 hertz in our line, so we have to filter the signal within 1 to 48 hertz. Then feature extraction, and we have to extract different features in time and frequency domain. And then classification approach and identification of mental state. Well, this is the first step of our easy signal acquisition. We accuse the signal in biomedical lab quit, and we use biopack and MP36 system. And here we use the single channel EEG, and you can see that there are different reasons in head, where in the scalp where the channel has to be set. And the subject selection, for subject selection we have to consider different status, that is the subject have don't have any history of seizures, and he didn't have any headaches, meant, or his mental status was totally good, that is his control subject. And he didn't have any mental disorders like schizophrenia or Alzheimer's disease. Well, so, and for the easy system setup we have to use blowout gels here in the electrode. Then we have to press the electrode inflexibly into the mark and clean locations in the head or skull, and have to confirm the full contact from electrode to the conductive gel in the scalp. And then we have to confirm the minimum impedance here between the electrode and the skull. Well, now easy signal acquisition, we have used a test condition for using an acquisition, and we have taken 15 trials for each subjects. 5 subjects took part in our experiment, and the experimental conditions was in happiness conditions. The subject was shown comedy movies in the computer screen, and like the movies of Mr. Bean. And in sadness condition, the subject was shown some tragic documentaries from YouTube, real tragic documentaries, so that he can be sad. And the easy signal was acquiesced. And for anger, it is really fascinating that he was slapped several times, and he became angry. And at that state, where we took the signal. And for fear state, he was threatened that if he uh, go out of the lab, he will be punished. And for surprise, uh, giving surprise, at last he was given a prize money, and he was really surprised. And the signal was taken all over this time. Well, now additional pre-processing. And for there, actually in easy signal there are some noises from our EMG signal, that is the signal from our muscle. And there are some noises from EOG signal, that is the signal of our eye, right? So we have to use smoothing at first, and we use biopack and acknowledge software for uh, smoothing. And for filtering, we have to use bandpass filter from zero point 0.5 hertz to 48 hertz. And because the line frequency is 50 hertz, and it is integrated with the signal, right? So we have to uh, cut out the line frequency. And we also used FIR filter to remove linear trends. Well, so this is the feature extraction, and here we have to extract different features in the time and frequency domain. In time domain, we extract the features like mean, median, standard deviation, skewness, and catharsis. And in frequency domain, we have extracted the features like fast Fourier transform, uh, PSD mean, PSD max, etc. And A50 mean, A50 max. Well, so here you can see the feature extraction, and here you can see the different bands of EG signal, and this is the main raw EG signal. This is delta, theta, this is beta, and this is gamma, right? And this is done by acknowledgement software and using MATLAB. Well, so now let us switch to our discussion part, and here after taking all the features, we plotted them, uh, and we compared the results, and here you can see that here the time domain properties are plotted, especially the standard deviation. And after plotting all the features of time domain, that is mean, median, standard deviation, skew, and kurtosis, we found that the standard deviation feature is good to compare the result. And here you can see that for happiness it varies for here the x-axis shows the different trials, that is 15 trials, and y-axis shows the values of the different features in time domain, right? So for the past, this is the first subjective one, and here this is just sample, and here you can see that for happiness it is varies from point 13 to point 20. For sadness it is varied from point 16 to point 28. For anger it is varied from some range. For surfeit it also varied from some range. And and the conclusion we found here, the comment we found here, that for easy and happiness condition is the most significant, because it varies a little, point 13 to point 20, that is point 0.07. So less variation of different over different trials for happiness. And on the other hand, for sadness condition there was least significant, that is greater variation over different trials. So for happiness we can easily identify a person, or for in happiness condition using easy signal. Then let us see about the uh, variation of PSD mean, that is in frequency domain. And here you can see that a small transformation of time domain properties with 15 independent trials. And you can see that fluctuation of EG signal in happiness, sadness, and different condition here. And you can also see that happiness is just shown in no fluctuation. This is flat, right? So there is a little or no fluctuation actually with different trials. So we can say that happiness is for happiness condition it is most significant, and there is less variation over different trials. And for surprise and fear you can see that there are least significance, right? But in the they have greater variation over different trials, right? Well, now let us see about the PSD max over different trials. And here in this car you can see that all cars are swing more or less except the happiness. So happiness, the conclusion is the happiness curve varies a little, but that portion is negligible. The sadness, anger, and surprise curve are disordered like an identical curve, but fair are PSD max curve distorted and most and very unstable feature. So we can say that fair cannot be identified or cannot be recognized in different trials, and it is not stable over different trials. So to conclude, we can say that our first observation is over time and frequency domain. The frequency domain features give the better performance than time domain features, that is PSD mean, PSD max is, or A50 mean and A50 max gives better performance than the time domain features like mean, median, standard deviation, skew, and kurtosis. And here in observation, the observation 2 is in time domain. The most significant feature is standard deviation, so we used this standard deviation over maximum, minimum, mean, standard deviation, skew, and kurtosis. And the third observation is in frequency domain. The most significant feature for emotion detection is PSD mean over A50 and PSD max. And we can also conclude that the most significant condition using all the effective features from time and frequency domain is happiness. The least significant emotion is fear. That is, we cannot identify fear with different trials. It is not stable over different trials, but happiness is stable over different trials. And the nominal distribution is sadness, anger, and surprise. It cannot be identified easily, or they are just a normal distribution. They are not stable, or not, they are neither stable nor unstable. But we have to say that the exactness of identification can decrease with rising number of subjects. But the problem can be overcome if we use conducting easy headset with increasing number of channels, because we have used the channel with only one channel easy acquisition system, and we can use machine learning techniques like ANN or SVM for classification for increased performance of different emotions. Well, so what are the future works? Our future works includes to use easy headset with more channels and to add machine learning techniques for classification approach and to detection different differential detection of mental illness, psychiatric disorders, autism, dementia, Alzheimer disease, Huntington disease, or Parkinson disease, and these are the references. And at last, thank you very much all for uh, watching my presentation, for listening my presentation, and it is really a proud, it is really a honor for me to speak here in front of all of you. And thank you everyone for giving me the floor to speak here. Thank you.